Delighted to welcome Jorg de Ruijter, who is Research Team Leader at VTT.
All right, I realize I'm the last thing standing between you and lunch, so please bear with me. It's only 10 minutes. So I'm leading indeed our synthetic biology research team at VTT, and in the next 10 minutes I hope to convince you why collaborating with VTT could be very valuable to drive your biotechnology innovations even further. So VTT is the Technical Research Center of Finland, and as a research and development company, our core purpose is to have an impact on the world around us through science-based innovations, trying to solve some of the big challenges we are now facing in the world. So VTT has 3 business areas and 14 research areas, including, for example, quantum computing, as you can see, biotechnology, microelectronics, energy, but also, of course, industrial biotechnology. So VTT has decades of experience in industrial biotechnology research and development, and throughout the years we have worked with a wide range of different production hosts, like yeasts, bacteria, filamentous fungi, plant cells, and with these we have made a very wide range of end products like bioethanol, different acids, microbial lipids, biocolors, recombinant proteins, and also whole cell solutions. So with regards to the development of efficient biotechnology production processes, VTT has both experience and capability to address the whole R&D process. So starting with bioinformatics-based modeling and design of enzymes and cells, through strain engineering and screening, all the way up to bioprocess engineering, downstream processing, and also piloting. And as you can see in the video that has been playing behind me, we also have the facilities to match that. We have a state-of-the-art, high-throughput screening platform, over 80 bioreactors ranging up to 1,200 liters with various downstream processing equipment and an advanced bioanalytics infrastructure. So now I would like to show you a few case examples of where we have worked together with our customers to create value and improve their biotechnology processes. So given VTT's extensive expertise in yeast engineering and in bioethanol production processes that use a variety of different feedstocks, Lief by Le Saffre chose to work with us to improve the economics of their bioethanol production process. So in this project, we successfully engineered their industrial bioethanol production strain to work more efficiently on the complex sugars of starch as a feedstock, while also decreasing the need of adding external enzymes. In addition to that, we also improved the bioethanol yields, meaning that the overall costs of their production process were successfully decreased. Then with Cargill and NatureWorks, we aimed to create a new and efficient way of producing environmentally friendly bioplastics through an improved production host for lactic acid. So here our scientists engineered a non-conventional yeast host for more efficient conversion of plant materials into lactic acid. So this yeast production host was able to grow on both glucose and xylose using a low pH process, and thus successfully reduced the overall production costs. Moreover, as you can see, our lactic acid titers were up to 92 grams per liter, so really making this a proven and efficient process to go from biomass to bioplastics, while also demonstrating that using a lignocellulosic feedstock in a second generation process for this purpose is feasible to do in large scale. Then the Finnish company Finfoam came to us having soy molasses as a side stream that they would like to utilize for bio-based production of plastics. So in this project, we engineered again a yeast that was able to directly ferment the soy molasses into lactic acid, and then together with other research areas at VTT, we also developed workflows for efficient lactic acid purification and polymerization into PLA suitable for bioplastics. So here we really established using a new type of raw material to replace oil-based plastics and help to create biomaterials without increasing the use of arable land, while also reducing carbon emissions, so ticking all the nice sustainability boxes. So to highlight this, we provide our services really from lab scale to piloting scale, all under the same roof at our location in Espoo in Finland. We have a wide range of synthetic biology tools available to engineer our production strains. We can work with at least over 50 different strains, from yeast, fungal, bacteria, plant cells. We can do it all. And we can work very efficiently using our high throughput infrastructure for strain construction, screening, bioprocess development. And then also indeed for those processes that are too complex to be solved by biotech tools alone, we can work, for example, together with our chemistry experts and combine the biotechnical and chemical routes into the same project. Then over the years, we have developed a strong internal and external partner network where we can really work together with these partners to help us solve even the toughest problems for our customers. But then, it might not be only our biotech expertise that's interesting for you. That's why I'm making now a small sidestep to our biomaterials research at VTT. And as you can see in the picture here, in this area, we like to go really big. So what you see here is our brand new VTT airlet pilot line. So it's very nice and shiny still. And this is a globally unique state-of-the-art facility for dry web forming. So this allows waterless, non-woven, and board forming production with increased efficiency and a reduced energy use compared to traditional processes. So here in this biomaterials research area, we really try to use forest resources to provide a steady stream of biomaterials innovations. And here also we truly believe that true innovations are created when an exceptional business case is supported by science. So for example here, we've been working with Henkel, and they sought to replace fossil-based foams used for packaging with a recyclable and renewable alternative made from cellulose foam. And in this project, VTT oversaw the construction of a dedicated pilot line to scale up Henkel's material recipe from lab scale all the way to industrial level. And with this pilot line, we demonstrated both technical feasibility, but also added value for the company. And as the result, Henkel has now a viable product and production process, generated new intellectual property, and obtained a technology that can be transferred to the production lines of Henkel's customers. So VTT's motto is beyond the obvious. So here I want to take a sort of unexpected outstep to an unexpected alternative form of packaging, being outdoor clothing. So as you might know, the winters in Finland can get quite cold, and that's only one of the reasons why we are participating in the EU-funded Penguin project. So in this project, we have worked on using wood cellulose to turn it into textile fibers for the manufacturing of insulated outdoor clothing. Then together with the partners, these fibers will be used to design clothes that mimic the way penguins stay warm and dry in extreme climates. So in here, in this project, we are creating an alternative to animal-based down and synthetic textile fibers using a bio-inspired approach for sustainable outdoor clothing. So, thank you for your time. We're 3 people here today. We'll still be around till the end. Please come talk with us if you think that VTT could be a good partner for you to make sure that also your product is becoming part of making bio the new normal. Thank you very much for your time.